of the outer line there. The outer line is the green line. So you want to subtract that y value from the 6. So that's an x squared, because that's your radius, dx, minus, because you're subtracting out that empty area still. So you're going to do a minus pi times the integral from 0 to 2. Now that inner radius is still going all the way up to the y equals 6, so that top value is still 6, minus the entire, that equation that dictates the y value of the inner thing there. So it's going to be the upper line, this line here, the blue line. So you're going, so this, so that's going to be to the 4x minus x squared, and then that whole thing squared because it's still radius dx. And then, obviously you know how to evaluate that. You expand them, and then you take the integral of each, and it's gonna, it'll get a little messy, but it's okay. It would get really messy if I did it all out on here. But, when I worked it out, the answer I got was 64 pi over 3, so when you work that out, either in your homework or in your notes somewhere, make sure you get that. But yeah, basically it's just this top integral here. Let me find like a pointer or something, maybe. Maybe not. Here, highlighter. So this top integral here, you're going from here, this top line, you're rotating around to this green line, and you're taking that whole volume in there, this whole thing, and then you're subtracting out, since you only want that blue volume there, you're subtracting out this part, the empty part. So this part here is where you're subtracting out from the y equals 6 to the blue line. So you're subtracting that, and what you're left with is that blue area, which is the 64, or the blue volume, which is the 64 pi over 3. Okay, one final example. This is just one where it's around the y-axis, so this one should be relatively straightforward. Throw up a graph, let me throw up a graph here real quick so it's not too long. So, real quick, just get this line into the form you're familiar with. So, y equals 6 minus 3x. So, y is equal to negative 3x plus 6. So, your line's going to look something like this. Coming in at y-intercept 0, 6, where the slope is equal to negative 3. So that means down here, this value is going to be 2, 0. And then you're bounded also by each of the axes, so that one y-axis and x-axis, and then you're rotating that entire thing around the y-axis. So this is actually a super simple example. It's just like the one that we did at the very beginning, which is like when you rotated around the x-axis, you got a cone. Same thing, when you're rotating around the y-axis, you're getting a cone. So, just to do it real quick, you're going to get your volume equals pi times the integral from, since you're doing a y-axis this time, you're rotating around the y-axis, you're going to cut your slices perpendicular to it, so they're going to be going that way. So keep that in mind, don't get confused. Always sort of draw those in for yourself first so you don't mix it up. So your boundary values are going to be from 0 to 6, since they're y. So from here to here, 0 to 6, times the integral from, you want the x value this time, right, because you're going from right to left instead of top to bottom, because you're doing a dy. So that's going to be the x value of that line minus 0 squared dy this time, because you're cutting slices perpendicular to the y-axis. So then what you want to do, the next step, since you don't have to subtract out any empty space, the next step would be to replace everything in terms of the y, of the derivative. So to do that, you need to solve this equation right here for x. So just to do that real quick, negative 3x equals y minus 6, and x equals y minus 6 over negative 3, or 6 minus y over 3. So now that you have that value, you substitute that in for the x so that you get everything in terms of y. So that's pi times the integral from 0 to 6 of 6 minus y over 3 squared dy. So now you have everything in terms of that. You can take out the constant term, pi over 9 times the integral from 0 to 6 of, expand that, 36 minus 12y plus y squared dy. Do the integral on that, so pi over 9 times 36y minus 12y squared over 2 is 6y squared plus y cubed over 3 from 6 to 0. And then evaluate all that out. You should get 8 pi as your final answer. And then, of course, if you wanted to check your work as you're going along, just do the regular volume of a cone formula. I mean, you're not obviously going to be able to check all of these because some of them are going to be weird shapes when you rotate them. But for ones like these, it's probably worthwhile. So 1/3 pi r squared h would be 1/3 pi times 2 squared, which is 4, times the height, which is 6. So that's 24 over 3, which is 8 pi. So that's right.